Right. Hello students, how are you all? I hope you all good. And once today early 5 minutes before I was started just to check whether this screen is good or not. So you are, and if I write everything it was properly is there or it is just like glittering manner is there, you have to check. Continuity and differentiability. So we are discussing this chapter number 6, continuity and differentiability. Firstly come to the live and check first. So this 5 minutes just for checking purpose. So if you are not coming also it's no problem. Now still it is 4 minutes is left. Just you all check once whether it was screen is proper or not. Your in YouTube that glittering manner it was coming or not, or it was everything is fine. You just need to comment. Check it. Check madam. Same method or students didn't know the- There's no problem. Okay. All right. Okay, good only, sir. Okay. Where is remaining students? Satishwar, Himanshu, Shubham. Okay, you're still 3 minutes, is there? Okay, I will wait for you all. Let me keep in this way. All right. Shubham, good afternoon. Where are you? I found you are saying good afternoon, then later I am not finding you. Say to your friends and then bring everyone to the class now. If you are coming, then I can start. Still 1 minute is there. I'm waiting for that. Meanwhile, I write something. Right. Okay. You all came back. I hope who are present who came now. I did not get any comments. Shubham, hello sir. Okay, good afternoon, Shubham. Then where are remaining? Remaining, say who came. You all say just good afternoon because it is 2:15. You have written. Then I have to start. Shubham, good afternoon. Okay, next, who is next? Only Shubham is present, remaining not present. Where is this Satish, Himanshu, Kirtan, Trapti, Jinisha? Oh, Jinisha, good afternoon. Priyanshi, Deepal, Akshit, Tanish. Fast. If you have said firstly good afternoon, then I can go for teaching for you all. Yesterday, which I was taught, those only again we are going to repeat, and then you can understand today this continuity full. Then we'll complete maximum this all example problems. Okay. So I was listened only today two members. Good afternoon. One is Shubham, and there is Jinisha. Where are remaining good afternoons? Firstly, say so that we'll start our class. Jinisha, you take and check who are not coming, and then tell to them to come. Where is that Priyanshi and all girls? And Shubham, you check all boys need to come. Right? How much time I need to wait? Still 2 minutes extra also completed. Right, fast. Okay, sir. Okay. And wait. Oh my goodness. Because of sweat, it was going to be very difficult for me. Priyanshi, yes, good afternoon, Priyanshi. Next. So Jinisha, Shubham, Priyanshi, Tanish. Okay, Tanish, four. Next, four students. But I'm not finding in this number. Viewers place, I'm not finding Tanish Jain, your name. Check, fast. All right, let me start then, whether you will come or not later, because I don't want to waste my time. I will start. Okay, listen. Yesterday we discussed about continuity and differentiability. In the mainly we are discussed about continuity. This chapter consisting of two parts. First part is about how to check continuity. Second part is how to check differentiability. Okay. So continuity is going to be first exercise fully continuity how to check, and then second exercise fully how to check differentiability. Okay. Okay, Jinisha, thank you. And let me complete. So condition to check continuity at x is equal to a. That means at one point, how to check the condition of that function, given function, for example, f of x. To find this f of x, so to check this f of x function is continuous at x is equal to a. For that, this is your formula, that is right hand limit is equal to f of a is equal to left hand limit. If this condition is satisfied, then we can say that at x equal to a, f of x is continuous. Otherwise, it is not continuous. Remember again carefully this. If any function satisfies at a, at x is equal to a, right hand limit is equal to f of a is equal to left hand limit, then that is called as continuous at x is equal to. I'll take one example so that you can understand clearly again. Okay. So yes, we are going for our first example now. Example number one, yesterday, which we are not found, that we are going to discuss again. So first example now. Example number one, I have your textbook. Right. So there are some definitions and properties, but which is not at all required for your examination point of view. You just go through your textbook, you can understand all the definitions. So nothing to worry about. All. So now here it is example number 1. So example number 1, discuss the continuity of the following function at x is equal to 0. So we need to discuss about continuity. That means we need to check whether it is continuous or not at x is equal to 0. So then f of x is equal to x minus modulus x upon x. X is not equal to 0 and 1 when x is equal to 0. So what is meaning of this? So here remember carefully, I already said for you, if they given x is 0, greater than 0 comes, that is your right hand limit, less than 0 comes, that is your left hand limit. Okay, so now if x is not equal to 0, this is your function. If x is equal to 0, if function is equal to 1. Now what is this x is not equal to 0 means? This function only for right hand limit or maybe the left hand limit, because x is greater than 0, x is less than 0, we consider this function only. Okay, so you are understood that. So now I'm going for direct method. I'm not going for this modulus x, taking separate and doing those all. I'm directly substituting and directly completing. Okay, just observe now. So now first f of 0. So f of 0 is equal to, anyhow I'll complete like this 3 parts. So f of 0 is equal to, what is f of 0? So what is function that f of 0 is 1. So that we can write f of 0 is equal to 1. This is your equation number 1. Next one, I'm going for right hand limit. So what is my right hand limit? So right hand limit is nothing but f of a plus 0. So f of a plus 0 means f of, here a is nothing but how much, x is equal to 0 given, this is a. Okay, so a is 0. So here I'll write a is equal to 0. Just substitute 0. 0 plus 0. Next. So then limit h tends to 0, f of 0 plus h. So now what is function for right hand limit? Right hand limit function is that this is x minus modulus x upon x. So just substitute wherever x is there, 0 plus h. So now we can write limit h tends to 0. What I am doing? So here x place we need to substitute 0 plus h. 0 plus h is nothing but h only. So directly h substitute. So I'll write here it is h minus modulus h upon h. So this becomes as 0. So limit h tends to 0, 0 upon h. 0 upon h is nothing but 0. So now we can write limit h tends to 0, 0. So 0 is there means automatically we can write as 0, and from these two itself, these both are not equal. You are finding here f of 0 is 1 and f of a plus 0 is 0 you got. Means right hand limit you got 0 and f of 0 you got as 1. So that here itself we can say that these both are not equal. So that function is not continuous, we can say. But we can check even left hand limit also. You can choose anyone, right hand limit or left hand limit. But if these both are equal happen, you need to go for left hand limit, and that also you have to solve. But anyhow, I'll solve for you your understanding purpose left hand limit also. So f of a minus 0, that means f of 0 minus 0. Then after that, what I can write? Limit h tends to 0, f of a minus 0. Sorry, f of 0 minus this part is h. 0 minus h. So now 0 minus h, left hand limit also same function, just substitute there what you are going to get. So that is equal to, you will write here limit h tends to 0, Now we are going to substitute 0 minus h means minus h we are going to substitute wherever x is there in that place. So now substitute there, you get as minus h minus and modulus minus h upon, and this x is nothing but that is minus h. So now let me check what we are going to get. So now limit h tends to 0 minus h minus, see here you modulus of minus h is nothing but h. So write as h upon minus h. So you are going to get your limit h tends to 0 minus 2h upon minus h. Minus minus cancel, h cancel, you get answer as 2. You get answer as 2. Now from this also what you are finding here, first one is 1, second one 0, third one 2. From this what we can say, these both are not, these are not equal, therefore we can say that it is not continuous. So who is that buffering? Deepal, you have to refresh your connection so that it is everything is good. Okay, so here I am finding my system also is there. I was checking everything was fine. So only your system problem, just refresh it so that you are going to get. Okay, so your signal problem, yes, what we can do with that. So my signals are good now. Okay, so now here you all understood now. So here f of 0, 1 you got, RHL, right hand limit you got as 0, left hand limit you got as 2. These all equal or not equal? So we can say that these all not equal because first one 1, second one 0, third one 2. So at last I'll write here it is. This step I'll write, that is f of 0 is not equal to RHL, not equal to LHL. Therefore, f of x at x is equal to 0 is not continuous. Clear? Anyone having any doubt in that? You all understood now? Okay, say Deepal, what happened? Still you are feeling that problem only? I hope everyone is finding the answer properly, I think. No doubt. Okay, if you are not having doubt, then we'll go for second example. Can I go for second example? Fastly inform so that we'll go for second. Okay, it is clear. Okay. Okay, so now we'll go for now second example so that you can understand. See here in the modulus there is another method also there. What is that method? You have to take this modulus x is equal to, then you know that modulus function is less than x if x is greater than or equal to 0, minus x if x is less than 0. You can use that also and you can make again another function and you can do, but I am doing direct method that was easiest for you all. Okay, let me go for next. Second one. This much only, nothing is there. That's the reason I said revise your limits and derivatives of your 11th standard so that it becomes very easy for you all. Alright, so now second question. Test the continuity of function f of x is equal to modulus x plus 1 at x is equal to 0 and x is equal to 1. So means here at 2 points we have to check whether this function is continuous or not. So first one it is x is equal to 0, second one it is x is equal to 1. So now we will check now. So what is the possibilities are there? Okay. So let me go for now this. This is what they given. Nothing is given more than this. So it is x is equal to 0 or whichever it is, just directly we need to substitute and we can find. So function is same even if it is greater than 0, if it is less than 0, if it is equal to 0 also, same function. Okay. So now let me solve it. So now our solution for this, f first at x is equal to 0. So now f of 0 is equal to, just in this function wherever x is there substitute 0, modulus 0 plus modulus 0 plus 1. So you get as 0 plus 1, that is nothing but 1. So this gives us equation number 1. So now we are finding at x is equal to 0. Okay. So now right hand limit. So right hand limit means that is equal to f of 0 plus 0, that is equal to limit h tends to 0 f of 0 plus h. So now wherever x is there, substitute now 0 plus h. So when you substitute 0 plus h, what we get? 0 plus h plus modulus 0 plus h plus 1. And here it is limit h tends to 0. So now here 0 plus h means what you get? H. H plus 1 is nothing but h plus 1 only will get. Only one single digit is there or single number is there that having minus symbol, then only you can change into the positive symbol in the modulus. If two numbers are there, you can write as it is. So now what we write here, it is h plus h plus 1 limit h tends to 0. H plus h 2h. So limit h tends to 0, 2h plus 1. Just substitute h is equal to 0, remove limit, then 2 into 0 plus 1, that is nothing but 1. Equation number 2. Now same method, left hand limit now. So left hand limit is equal to f of 0 minus 0, that is equal to limit h tends to 0 f of 0 minus h. So now previously what you done in the right hand limit, 0 plus h is substituted in the x place. So this is limit h tends to 0. So limit h tends to 0. Modulus of minus h is nothing but plus h plus this, like this is there means we cannot change anything. We need to write as it is. 1 minus h. Minus h plus h get cancelled. So you get limit h tends to 0, 1. 1, equation number 3. Now tell to me from 1 to 3 means first f of 0 we found, that as 1 we got, right hand limit we find, that is also 1 you got, left hand limit also we found, then we got that also 1. So from 1, 2 and 3 what we can say, whether it is continuous at x is equal to 0 or not. Shubham is correct, it is continuous. So anyone having any doubt in this? Again, we are going to solve for x is equal to 1. We need to test for x is equal to 1 also. Himanshu? Yes, sir. Okay. Yes, Shubham, you are saying. Okay. Alright. I hope you all understood this. Yes, it is continuous. So at last we can write therefore from 1, 2, and 3. RHL is equal to f of 0 is equal to LHL. Therefore, f of x is continuous at x is equal to 0. Same method, x is equal to 1 also. Shubham, no doubt. Priyanshi, no doubt. Deepam, no doubt. Okay, that's good. Good to listen that. So now we'll go for our same problem for x is equal to 1 now. In offline, you can check this video, these solutions again, okay? And exercise number 15.2 graphs. There was shared for you all. Jinisha was asking me, so that I was shared for you all. So you just check your exercise number 15.2. PDF form also it is available in that same second video of linear programming description place. Okay, if anyone want, you just download it, you can get it. Okay, Jinisha. Yes. Okay. You are welcome, Jinisha. You done good job. You asked me, otherwise it is not possible to be given, right? Alright, now we'll take at x is equal to 1 now. So how to solve now x is equal to 1? First f of 1 form. So wherever x is there, substitute 1. So when you keep modulus 1 plus modulus 1 plus 1. So now 1 plus 1 is nothing but 2. 2 plus 1 is nothing but 3. This is your equation number 1. So now first we found f of 1 as 3. So now we are going for f of, uh, let me tell to you this. Okay, so we got f of 1 is equal to 3, and now we go for our next RHL. Right hand limit, because we are going in another method, f of 1 plus 0. So then limit h tends to 0, f of 1 plus h. Wherever x is there, we have to substitute now 1 plus h. So when you substitute 1 plus h, what we are going to get? First here modulus x means modulus 1 plus h plus another one modulus 1 plus h plus 1. So modulus will finish. So this is limit h tends to 0. Then again limit h tends to 0. Modulus remove and write add 1, 1, 1, 3. 3 plus 2h. Then just h plus substitute 0. Limit remove. So that 3 plus 2 into 0, that is nothing but 3. That is your equation number 2. Same method can you tell for this LHL? Oh, it is very difficult. If it is normal classroom, you are able to tell, but here it is very difficult. Okay, here again, 3 students who are fluctuating again, coming and going, coming and going. Just check that. So left hand limit is f of 1 minus 0, that is nothing but limit h tends to 0, f of 1 plus 1 plus 1, 3, minus h minus h minus 2h. Now just wherever h is there, substitute 0. So limit remove, then 3 minus 2 into 0, 3. So that is equation number 3. You are understood now this. Once again listen carefully, because you have to understand this. If without understanding I explain something, it cannot be good. Okay, so everyone observe carefully now. First, at x is equal to 1 means f of 1. Wherever x is there, substitute 1. Okay. So now 1 plus 1, so that you got at last 3. Now RHL means right hand limit, that is equal to f of 1 plus 0. So h tends to 0. Wherever, see here h tends to 0 is said, because of that reason. Wherever 0 is there, I am keeping as h. So f of 1 plus h. So f of x is this. F of 1 plus h means wherever x is there, substitute 1 plus h. So now 1 plus h, then modulus 1 plus h plus 1 is there, so that here plus 1 written. Now modulus plus 2 terms or 3 terms are there, as it is we have to write, so that 1 plus h plus 1. So 1 plus 1 plus 1, 3 plus h 2h. Now limit removed means then wherever h is there, there we need to substitute as 0. So now 3 0. So now 2 into 0 is nothing but 0. So that you get answer. Method now go for left hand limit. Left hand limit means f of 1 minus 0. Here 1 is nothing but a. Remember that. Here 1 given, because of that 1 minus 0. If here 3 given, 3 minus 0. 7 given, 7 minus 0. 10 given, 10 minus 0. That you have to remember. So here 1 given, that's what 1 minus 0, limit x tends to 0, f of 1 minus h. When you leave h tends to 0, wherever 0 is there in this, that place you are keeping as h. Now remember f of 1 minus h. So wherever x is there in that place, I need to substitute now 1 minus h. So substitute here x place 1 minus h, and again x place 1 minus h plus 1. Now check carefully here. If modulus is there, we need to keep like 2 terms, 3 terms are there, as it is we are right now, and all 1, 1, 1, 3 minus h minus 2h. Then limit remove, then wherever h is there, substitute 0 now. 2 into 0, that is becomes a 0, so you got as 3. So at last from equation 1, 2 and 3, we can say it is Janisha said continuous function. Yes. So we can say that it is continuous function. Okay, you are understood now this? Any doubt? So at last, therefore, from 1, 2, and 3, f of x is continuous at x is equal to 1. Clear now? Anyone having any doubt in this? Check. Still, if anyone having doubt, you can inform to me. It is clear for everyone. Second question clear. No doubt, Tanish Jain. Yes, sir, fully understood. Okay. Because if you are understood this, total exercise is easy. And same method only you have to solve. Okay. Modulus function, kindly go in this method so that it becomes as very easy to solve. If you go for another method, you may get confusion when you are writing the functions. Okay. Okay, Priyanshi, no doubt. Then we'll go for our third problem. That is about your second. Now we'll go for our third. Okay. So now third question. It is easiest one. Again. Show that following function f of x does not continuous at x is equal to 0. Very nice. So now previously we need to check continuous here. X is equal to 0 place does not continuous means you need to prove that LHL is not equal to RHL, or maybe the f of 0 is not equal to RHL, or f of 0 is not equal to LHL. If you prove any one also, we can say that it is not continuous. Okay, what is function first? F of x is equal to e power 1 upon x upon 1 plus e power 1 upon x. 0. X is not equal to 0. X is equal to 0. Nice. So x is not equal to 0 means, so I already said for you all, so it is x is greater than 0, x is less than 0. That means RHL also, LHL also, same function we have to use. And only for 0 we have to use this 0. Very simple. So now first one, we go for the first one. So at x is equal to 0, they say. So now first f of 0. F of 0 means if x is equal to 0, what is our function? 0. So that write as 0. Equation number 1. You find anything that is LHL or RHL, anything fine. So I may find as RHL now. So I'll take RHL. So RHL means f of 0 plus 0, because here 0 is there, that's what 0 plus 0. Then limit h tends to 0, f of 0 plus h. So now wherever x is there, I need to substitute 0 plus h. Means this is our function. In this place, wherever x is there, there you have to substitute 0 plus h. 0 plus h means what do you know? H. Just substitute that. So what you are going to do? So that is limit h tends to 0 e power 1 upon h upon 1 plus e power 1 upon h. In this denominator also, common e power h, what you are going to get? So e power 1 upon h, e power 1 upon h common. Then what you get? Here first 1 upon e power 1 upon h plus 1. You are understood this? See here, e power 1 upon h I common. Then here only 1 is there. So 1 place, if you want to common, we need to write 1 upon e power 1 upon h. Here e power 1 upon h common, that's what 1 upon e power 1 upon h. If 7 common, 1 upon 7 we have to write. So I hope you are not finding and you cannot get any doubt in this. So finding any clarity was missed or what? It video is not clear. What happened? Okay, let me check again back. Same problem again. Same problem again. Now, refresh. Refresh. Exactly half an hour after it was started. Exactly half an hour after it was started. Exactly half an hour. Now check. Now check. Same only. Connection is unstable. What can I do? Yes, Shubham, you are saying, but still some students cannot get right. Yes, Shubham, you are saying, but still some students cannot get right. Ma'am, switch on that light also. Switch on that light. I think it is signal problem only. It is not our problem. I think it is signal problem. Okay, if everyone agree with the Shubham, inform to me so that today we'll continue in this way only with the voice. So that today we'll continue in this way only with the voice. It is not a problem. It should not be.